For our project, we chose a problem that involved laying cable across a parking lot. My partner Alyssa and I, Judith, had to work with a parking lot with the following dimensions. As you could see, the parking lot is not a perfect triangle, making it have different measurements along its sides. For this problem, we had to connect cable from building A to building B across the parking lot to figure out which way laying cable was the cheapest and the most affordable. The problem showcases 5 different options that would result in 5 different prices to pick from. Path A goes across the parking lot at a slope from building A to building B. Path B and C go around the perimeter of the parking lot. And things get a little bit more complicated for path D and E. As you can see, it takes some of the perimeter and then goes across the parking lot. A big element to consider during this problem is that laying cable around the parking lot cost $8 per feet, while laying cable across the parking lot cost $11 per feet. As we go into path A, my partner and I decide to use the Pythagorean theorem since it is pretty straightforward and it'll give you a precise and accurate answer. And the formula for that is a squared plus b squared equals c squared. And we already have the measurements for a squared and b squared, making it a lot easier for us to complete since we only have to find c squared. As you could see, the numbers we're going to plug in are 300 and 240. And once we plug that into the formula, we get c squared equaling 147,600. And when we square root that, we get approximately an answer of 384. And when we multiply that, we do get a total of $4,226.06. For path B, we take the easiest approach that would make things the least complicated, and that pretty much is adding up all the different sides. We add 300 plus 240 plus 60. We make sure not to add the other sides that aren't included. Once we get that, we get a total of 660. We multiply it times 8 because it is on the outside of the parking lot, and we get an answer of 5,280. For path C, it is pretty easy, just like path B. And we add up all the sides. $300 plus 300 plus 60, and it gives us a total of 660 multiplied times 8 because it is on the outside, and we get again a total of 5,280. For path D, things do get a little bit more complicated because, as you could see, the cable lays outside of the parking lot and then cuts through it. And what we did for this was create a cost function, and we used c of x to represent that. We used x to represent the cable that lays outside of the parking lot, and d to represent the cable that goes through the parking lot. And d is going to equal our distance formula. And our distance formula looks something like square root, and under it would be x minus 0 squared plus y minus 0 squared. And then we plug in our variables, which is 300 minus x squared plus 240. And then we plug it into our cost function, which is 8x plus 11d because of the measurements and the cost of feet per squared. And we plugged that into decimals, and we got an answer of $4,211.69. And for path E, we took the same approach. We used our function c of x to determine our cost, and we used the distance formula as well. A little reminder that c of x is 8x plus 11d. As you can see, the diagonal that crosses through the parking lot is d. The measurements in between x and d is 240 minus x. And then what goes straight across is 300, right above D. Our distance formula is 240 minus x squared plus 300 squared. When we plug it into our cost formulas and plug it into decimals, we get a total of $4,184.95. And with all the answers displayed and figured out, we could determine that path E is the cheapest and the most efficient, and it's a pathway that should be chosen. And that is that. Make sure to like, share, and subscribe, and thank you for coming to my TED Talk.